Hello everyone, this is Giovanni Fanigliulo from Studio di Ingegneria delle Strutture, an engineering firm in Cosenza, Italy. This presentation is about Cernichiara Viaduct and the technical analysis and structural rehabilitation design of a viaduct using Allplan bridge, as the title of the presentation suggests. Now, we'd like to give you some notions about the viaduct itself. Firstly, it is located at the beginning of the A2 highway named Salerno-Reggio Calabria. It is near the city of Salerno. It was built in the last years of the 1960s, and it plays a crucial role in the traffic management of the city of Salerno. Moreover, it is crucial it has a crucial strategic role in the a network of highway connections all along Italy. Now, here is some information about our founder. So this is the profile of Francesco Fanigliulo. He is a structural engineer. He has founded Studio di Ingegneria delle Strutture in 1998 and has been the owner ever since. He's a lover of bridges and steel constructions. He has implemented always innovative solutions in his projects, and in the last years been so building information models. He has implemented Allplan in his engineering firm since 2005, which he used for numerous interventions. And since 2021, he uses Allplan Bridge to carry out structural analyses and to realize beam models of bridges and viaducts. In the structural field, he has drawn up structural rehabilitation projects of viaducts with girders in reinforced concrete and pressed concrete, upper girder viaducts. He's an expert in structural modeling and reinforcement systems through the use of innovative materials such as UHPFRC, FRP, and FRCM reinforcement techniques applied to buildings, bridges, and viaducts. He's been a member of YABSE. He's a part of a group working on the degradation of structures, their durability, the evaluation of their residual life, and the extraordinary loads applied to structures. In this PowerPoint presentation, you can see the contacts, so phone number, website, and email address. Moving on to the next slide, here is a brief presentation of the viaduct. We've already said it has been built in the 1960s. It is a 6-span bridge. Each of the spans has a width of 18 meters. It has a 66-meter wide central arch, and the entire viaduct was cast in place. Moreover, the viaduct itself is long approximately 142 meters. Each pylon is framed in two directions, and it is made by 4 connected columns transversely, and each column is connected to the other one onto an horizontal axis with beams on 2 levels. The entire viaduct is an icon all throughout the history of our highway, of the A2 highway. But due to its age and the normative updates of anti-seismic laws, it has been deemed necessary to carry out a seismic improvement and assessment of the bridge. It has been a challenge since Valoris Carl Consorzio Stabile had requested the improvement of the executive project and the realization of a BIM model to give ANAS SPA, the owner of the viaduct, a better solution. So, in order to do so, we had to order a 3D scan survey through laser scan technique We had to realize a model of the viaduct on Allplan Bridge, as you will see very soon in a demonstrative video. And we had to evaluate and structurally study the viaducts on Allplan Bridge. Now, the structural improvement of the Cernichiara viaduct was realized through the use of CFRP, so carbon fiber reinforced polymers, which are used in the aerospace field, and that allowed us to improve the mechanical characteristics of structural elements. Now, the employment of Allplan Bridge was decisive while identifying and solving various issues regarding the structure. We will now play a demonstrative video that will show you the project on the software itself. Before showing the video, though, we'd like to show you some pictures. This first one is the fundamental shape mode in the seismic analysis. This second picture, instead, is a deformation induced by the permanent load. These are the two pictures represent the deformation under seismic action. This is the model of the viaduct realized in Allplan Bridge. You can clearly see the 6 terminal spans that rest on the 3D framed pylons, whereas the central span is made by a part connected structurally to the arch and 2 spans that rest partially on the arch and partially on the pylons. On the left, instead, there's the data management structure and menu in Allplan Bridge. Now, the numerical model that was produced heavily influenced all successive elaborations, as it allowed us to examine the structure from every single point of view. It was therefore possible to understand every issue related to the realization of interventions on particular elements of the viaduct. Allplan Bridge was of incredible aid during this process of structural rehabilitation. The menu on the left is divided into geometry, results, and analysis. Let's start with geometry. defining the viaduct's profile, both on a plan and longitudinally. Clicking on axis plan, we can design the axis of the viaduct, and in this case, this was possible thanks to the 3D scan survey we conducted. Now, as you can see, the axis is identified by 3 characteristic points with fixed coordinates that define its shape and its development in space. The height instead is defined by the profile. Now, setting up a double axis system is of course clearly necessary when working on both on the planimetric and longitudinal aspect of the arch. Now, under the menu, we can see the axis plan and the arch's profile. Defining these elements was not that simple, since we had to process the 3D scan survey we conducted. However, in Allplan Bridge, as we can see, obtaining the numerical model was quite easy. This way, we were able to obtain the height and both the planimetric and longitudinal developments of the entire viaduct. Other axes, all connected to other secondary elements, were defined in order to realize the model. Subsequently, we defined the cross sections. The first one to be defined was the viaduct's cross section at the extremities. It shows a full T section and it is almost rectangular. And then after the viaduct's cross section at the extremities, we moved on to the structural section made by the slab of the deck and the 4 beams. The load applied is represented by the paving and the side curb. This section was duplicated and re-elaborated in order to define the current section of the deck, found as cross-section B. This cross-section B represents the continuation in the span of the viaduct, and therefore, thanks to Allplan, we were able to define the variating sections from the extremities to the deck. Afterwards, we moved on to defining the sections of the 4 pylons, and each pylon independently, to show the frame structure. Now, there are 4 double T sections connected along their heights with transversal beams. After this, through the progressive use of numerical model, of course realized in Allplan Bridge, it was possible to correct and adapt the model to what turned out to be the survey. This way, we obtained an accurate representation of the entire viaduct based on the overlapping of the surveys with the numerical models. The foundations, here called base piles 1 and 2, the types of foundations were instead defined by the original design documentation and were correctly placed thanks to the surveys we ordered. Now, the 3-dimensional model of viaduct Cernicchiara in Allplan Bridge was realized like this. What we're seeing now is the construction of the pylons of the foundation, where the arch begins and the pylons end transversely. Other elements, such as the abutments and their accessories, other than the section of the arch beams, were progressively defined together with the paving, the slabs, the transversal beams, and the heads of the pylons. After defining the single elements and having obtained the profile, we put together through structural members the spans. Now, this table shows us each span and how it was defined through the cross sections and how it was associated to the relative profiles and axis definition. This was done for each span, associating profile, section, and variation laws. Now, after this, we can see in the relative menu that each span has its own characteristics. Firstly, standing points, then cross sections, and variation laws. This was done for each of the structure's elements, and thanks to Allplan Bridge's ability to verify the various associations, the overall work proved to be way less complicated than expected from a project this complex. The final recalculation allowed us to have the model's destination. Of course, this model was then furtherly implemented to conduct structural studies and to plan structural reinforcement interventions. Now, I kindly thank you for your attention. This is the end of the presentation.